Alright, now we're on problem number 3. So in problem number 3, we're doing normalizing data. Normalize the plot and plot the following before and after. Compute the mean and standard deviation for each normalized data set to verify that you have normalized them. Sometimes you want to transform a set of numbers. Alright, so for example, all I did was copy and paste his code right here. Let's see what it does. Sometimes it's helpful to start on a fresh start. Clear all your variables just to make sure that you're not accidentally using a variable from the previous problem. Sometimes you want to keep them because the problems kind of add on to each other, but for now, it's fine. So this is the code that he gave us. Let's run it and see what it do. All right. Okay, so it makes a nice little two plots on the same row using this par mf row equals c12. So that means we want to have one row with two columns for our plotting, and then x is just a list of numbers from 1 to 20. So if you do 1 to 20 down here, it just fills it in. If you do 1 to 5, it fills it in. You can do 5 to 1, I believe, and it goes backwards. Yeah, so it's pretty smart about identifying here. Just use this range of numbers. So that kind of wasn't interesting because it didn't really yeah, I guess it did change much. So here the mean is 10.5, standard deviation is 5.9. So after we normalized it, now the mean is 0. Yep, the mean is 0, and the standard deviation is 1. Alright, so let's go through this a little bit. So that just creates the numbers from 1 through 20. That sets the plot scheme, and then you're plotting the list of numbers. There's the title main. So that's just the first one. And then the sub argument is this kind of subtitle very at the bottom. And what he's doing is paste these two, paste these things together. So just the text mean followed by the actual mean value, mean of x1, and then also the text SD equals, and then he takes this, finds the standard deviation of that list, and then he rounds it to the nearest fourth significant digit, and then all four of those things are pasted together to get this little line down there. Yeah, and sex is the size of the dots, yeah. So x1 norm is x1 minus the mean of that list divided by the standard deviation of that list. And we do the same thing. So this is the normalizing the list part, and to have a mean of 0 and a standard deviation of 1. And pretty much the same exact formula. And then he checks it. So the mean of it is 0. The standard deviation of the normalized version of x1 is that. Alright, so what we're supposed to do is the same thing for these numbers. So I'm just going to start. Uh-oh, what did I mess up? Yeah, okay. Okay, great. So the way that I'm going to start doing this is by copying and pasting what he's done. No. The formatting. Maybe I can fix it better. Yeah, that's my fault. It's not my fault. Okay. Okay, whatever. I'm ignoring it. So where are we at? Alright, so we want to now use x2 instead of x1. So we could go in here and change all of these references. It's kind of a lot of references. it might be easier to do what we did last time, where we kind of cheat a little bit by just saying x1 is now defined as whatever x2 is. Have I run these yet? Yeah, so now I got these. Did I miss the last one? Yeah, okay. Alright, so what if I do that? So now x1 is now defined by x2. I kind of lost what x1 is here. But hopefully that means that this should be a pretty smooth process. Alright. Did that work? I think it did. Okay, there you go. It's a mean. Well, let's check it out. So what is the mean? It's that. So first I thought it was 2.7, but then you see that it's times e to the negative 17, which is, for all intents and purposes, 0. And then what is 1? Boom. Yeah, we did it great. So can we do that? Again, x1 is now x3. Alright, what's the mean? Ooh, the mean is 0. What's standard deviation 1? Boom, doing it. x1 is now x4. What's the mean? Basically 0. I'm gonna go ahead and update this. 1. Boom. Do we have a 5? We do have a 5. x1 is now defined as x5. Terrible. Okay. Did I do this right? Yeah, okay. Alright, what's our mean? Our mean is basically 0 again. So we're still doing good. And standard deviation is 1. Alright. Alright, and that's the first part. So now we're moving on to part B, estimating parameters of distributions. If we were to collect fewer samples, we'd not expect the estimate of the mean to reflect the true mean very well. So kind of the law of large numbers, or the average of large numbers, whatever you want to call it. So we'll use a matrix to represent a set of experiments of different sizes. We'll try to determine how much our estimate of the mean and standard deviation depend on the size of the experiment. So each row will represent an experiment, oh boy, and each column an observation in that experiment. In each case, we'll do the same for this can be done using, determine how consistent the mean and standard deviation functions are for the sets of the 10 random normal numbers. Do this at least 10 times and compare the means and standard deviations of each time. Do it 10 times for 10 random numbers. Do it 10 times for 100 samples. Do it 10 times for 10,000 samples. And then, okay. All right. Where do we begin? So first, how about we just do 10 random numbers? R norm equals 10. So, why does it keep doing that? Alright, x1, R norm 10. Let's look at them. Boom. Alright. Do we have to do the scaling thing first? We shouldn't, because our norm is already sampling from a normal distribution. Yeah, okay. So let's just look at it. What is the mean of x1? What is the standard deviation of x1? Okay. Now, what should it be? If we do our norm. So the defaults should be the mean is 0 and the standard deviation is 1. So we should be getting numbers around 0, and that's kind of what we do. Some are negative, some are positive. Great. Okay. But the mean, yeah, the mean's pretty close to 0. And the standard deviation 0.9, it's close to 1. But we want to do this 10 times and then see what these numbers are each time. So maybe we'll do a for loop. For in 1 through 10. Let's see if this works. Oh, I have no idea if it did anything. Alright, how about you print out the mean of x1. Can we print two things at the same time? Can we? So close.